Afternoon, everybody. Always have a problem. I'm out in the shop. I'm acting like I'm cutting wood on my table saw. There we go. And I wonder what time is it. So I look up at my clock on the wall. No clock there. No clock there. Of course, for safety reasons, I don't wear my watch while I'm in the shop. But I got an idea. So I go to my favorite online retailer, put in big digital clock, and I look, and there's a couple. Wow, these are kind of expensive. That one comes with a woman. Don't want that one. Here's one. Nice big blue, 3 foot long. Let's check it out. Holy smokes, that sucker's $100 plus about $14 shipping. So I know I can do better than that. I remember I had some of these LED strips laying around from a past project, and I figure if I can cut two sections of these three LED strips, I can make my own display. Yep, sure enough. Tried it out. There it is working. And what I did is I got some of this white marker board. I had an extra piece laying around. I fixed the strips on here. You can see for each strip I had to drill a 16th inch hole. Did some ugly soldering. That's a positive and a negative lead on each one of those strips. Doesn't really matter where you connect on that strip as long as you connect to both of them. They're all tied together. So you've got 7 individual strips. Try to do a little wire management on the back here. Not sure how well that went. One of the things you're going to do is you're going to tie all the positive leads for each digit together into a single wire. Do that for each one of the digits, and that's going to go be your digit bus. Once you get it all wired up, write a little sketch, check it out, make sure everything works. You can see here it does. Now we're going to go into full geek mode. Don't say I didn't warn you, but we're going to talk about some electronics here. One of the things about 7-segment displays, each one of those segments has to have a separate input. If you got 4 digits, 7 segments, that's 28 inputs. That's not enough if you're using a regular Arduino. They only have about 13, 14 outputs. So what we do is a process called multiplexing. We send the digits down on the A, B, C, D, E, F, G lines, and then on the bottom you'll see that we turn each digit on. So basically we'll send a number, turn the digit on, turn it off, grab the next one, turn the next digit on, and we'll keep doing that. The good thing about a microprocessor is it can do it so fast that your eye doesn't perceive the change, and it looks like 4 solid digits. So we'll go in a minute, talk about how to do that in the Arduino code. First, one of the problems that you'll have is the Arduino pins can't switch the current that each one of these LED segments draws. So what you're going to have to do is you're going to have to use what's called a low side transistor switch. It's called the low side because it's between the LEDs and ground, or it's on the low side of your circuit. So what we're going to do is we're going to use an NPN type transistor and connect it between ground and our LED negative lead. Now you'll remember on when we wired this up, all of the negative leads for each segment are tied together. So you're going to need a total of 7 of these little circuits. Again, used a 1K transistor, or I'm sorry, a 1K resistor here, and a 3904 NPN type transistor. Those are commonly available. Before Radio Shack went out of business, you could get them there and pay way more money. On the high side switch, which we're going to use for the digit bus, it's called high side because it goes between, the switch goes between the 12 volts and your LEDs or your lights or your load or whatever you want to operate off of it. So there we have a representation of our LEDs, and of course this is on our digit line, so we're actually controlling all 7 segments for each digit. This is a PNP transistor. Going to have a pretty good size resistor on the base here. The problem with using a PNP in an Arduino, if you were to turn that PNP on, that 12 volts is going to go back to the output pin of your Arduino, and 12 volts on the output line of the Arduino will let the magic smoke out, and your Arduino will not work anymore. So what we need to do is we need to put in a low side driver, which this is very similar to the low side switch that we just used before. And what that driver does is it allows you to switch on, that's a NPN type transistor. Again, it's 3904 is what I used. You could use pretty much any NPN transistor, which is going to turn on and off that PNP transistor, and it'll do it safely without letting the smoke out. That's a 3906 on the PNP. Now we're going to get into the code for the Arduino. This is a standard IDE sketch. We're going to include the time and the timelib.h libraries. We're going to define each one of our digits and the appropriate pins on the Arduino. Here I've used 9 through 12, and that's because 2 through 8 I'm going to use for my segments. So digit 1 is on pin 9, digit 2, so forth, segment A. We're going to have some switches that we'll use to set the clock. We'll go over that at the end. Here we're going to do our setup. We're going to tell each one of these pin modes is an output. We're going to start the serial clock. That's the clock program needs that for the timing. We'll do all of our pin modes for our switches as inputs, and then we'll set all of those to high. We'll come down into our loop, and here we're going to have an integer named TMP. It can't use time because time is already used as a variable in the time library. So we're going to take our hours, multiply that times 100, and then we're going to add our minutes. And again, those are called from the time library. So now we have 11, let's say 11:45. So it's going to be hours 11 times 100 plus minutes 45. So we get one integer, 4 characters, 11:45. Next, we're going to go down and we're going to run a subroutine called display temp, or I'm sorry, display number. And we're going to pass to that subroutine that variable now, 11:45, which is our TIMP, temp. So we come down, we're going to take that 11:45 that was passed to it, we're going to store that as an integer called toDisplay. We're going to do a couple more definitions here. We're going to do a display brightness. We're going to do define digit on as high. All that's doing is telling the Arduino, when I say digit on, I mean high. When I say digit off, I mean low. We have a little for loop coming up. You can see I start out with an integer called digit. We're going to start out at 4. As long as the digit is greater than 0, we will subtract 1 every time we run through this loop. So we're going to start out at 4. And we have a switch case loop. We're passing that 4 to that. So with our switch case loop, where it says switch digit, remember that the digit is 4. So we're going to do case 4. And case 4 basically is going to turn on digit 4. Have a little delay built in there. That's just to keep from hammering the Arduino too fast. Once we turn that on, we're going to run a subroutine called light number. And we have the toDisplay modulus 10. Remember, toDisplay at this case is 11:45. What that percent sign says is divide 11:45 by 10. Any remainder that you have left over, pass that to light number. So 11:45 divided by 10 is 114 with a remainder of 5. So we're going to pass 5 to the light number. So we're going to store that as an integer called number to display. And again, I'm telling it if I say segment on, I mean high. If I say segment off, I mean low. We're going to switch number to display, which remember was 5. So we're going to go down to case 5, and we're going to turn on the appropriate segment. So I'm going to turn on segment A, C, D, F, and G. Those are turned on. Once I get the break, I'm going to go out of the switch case to the bottom. I'm at the bottom, so I'm going to go back to where I was sent to this subroutine, which is right here. Then I'm going to divide that to display, which was 1145, divide it by 10. Because it's an integer, it will only store the whole number. So now we have 114. I'm going to do another little delay here, and then I'm going to go back to my for loop. We decrement to 3. So now we're going to turn on the 3. We're going to do the same thing over again. We're going to write a 4 to the third digit. Go back, and we'll keep doing that until we run through all of the digits. Once we run through all of the digits and all the numbers, we go back to the top and start all over. One of the things that we skipped over was setting the time. This little statement here says basically if there's a ground on the switch 0, enter the set mode or set time mode. Set time, we're going to define a few variables. While the switch 0 is grounded, we're going to look for inputs from switch 1, which is your minutes. Whenever you press the switch 1, it's going to increment or add 1 to the minutes. If you get to 59, it's going to roll over to 0. I'm going to keep doing that. Same with the hours. Once it does all that, you're going to go to set time, and that's going to pass that time you set back to the internal clock that's defined in the time library. And pretty much it's just going to keep cycling through that. Once you get your code all squared away, then you're going to wire it all up with your Arduino. Here I've used a breadboard and an Arduino Uno. In the near future, I will probably switch that over to an Arduino Nano and a perf board setup, make it something a little more permanent. But for now, hey, this is working pretty good, and why change it if it's working? Once you're done with all that, you should end up with something that looks kind of like this. Clock that you can hang on your wall. A little something to be proud of. I can say not only did I save $100 with about $6 worth of parts, but I built it, and this is definitely a full-on nerd trophy. So if you like it, have fun. There you go. Have a good one.